Today I want to take a look at one of the many videos online that show how your view is affected by distance and altitude. And this goes into the whole debate about is the Earth flat or not. And here's a wonderful video, check it out, from Al K. I'll link in the description. And he went to some effort. He went out and he videoed this island from different distances, and you can see how the view is affected by getting closer to it, and how the view is affected by being higher above the ground or closer to the ground. And he went out and he did that. And then, as happens on the internet, someone decided to, quote, debunk it. And so they take his video and they pick it apart and they make criticism of it. And then this is Nathan Oakley. And so then someone comes along to, SciManDan comes along and debunks the debunk. And so here he has overlaid two of the images to show a comparison of how much of the island is presumably hidden between the two images. And then now the original debunker is joined by Ranty Flat Earth to debunk the debunk of the debunk. And they're going to do a comparison of two of the images and identify features and claim that in their version they're going to say you could see all the way down to the horizon on both images. And then and you know what, they're going to also introduce a new concept called, they call it compression, which you see how these two images here, the corners, they don't line up. They're not the same. They're stretched. Like this has clearly been stretched, and they call that compression. So we're back to SciManDan now, who can't let that stand. So he has to debunk the debunk of the debunk of the debunk. So it seems like the argument really is how well do these two images line up, and how do we make them line up? So what I'm going to do is I'm going to take these same two images from the original video. I'm going to capture those, and I'm going to put them as layers into my image here. So let's show you what we've got. We've got this image from, this is the down below image, 30.9 miles away, 3 feet off the water. And this image was taken from up high at 31.9 miles at about 300 feet above the water level. So I fiddled with it quite a bit, and I figured out that if I scale this image, we'll scale this one to 83%. Go. That gets it to line up horizontally with the other image. So let's do that. I'm going to call this one 30.9 feet, 83. Yes. Okay. And so that I can line them up, I'm going to drop some transparency in there. So I can do this. Bang. Look at that. Okay. Lined up the peak of the mountains. And we're going to try and use the features of the two images to get the width correct, to get the side-to-side, the horizontal views exactly to scale. So I've got the peaks lined up. The next feature that I'm going to use to line up is this little humpity hump right here. Turn the transparency off. Come on, transparency off. And so now I can, let's drop it right down next to it. I can go set back and forth, back and forth, back and forth. And you can look at the different features and how they're lining up. In fact, it's not lighthouse, whatever. Let's highlight some features here. There's the hump in that image. And there's the hump in that image. And what else can we see here? There's a hump right here. And it's here in this image. And there's like a shelf right here. Let's put it right there. And That shelf is right there. So now let's put the peak. Let's put the peak while we're at it. Put the peak. And yeah, that's right. So because I used the peak to line them up. So the peak lines up perfectly, but as you go down lower and lower on the mountain, the disparity between the two images grows. So let's do this again. Compare. You see that lines up with those purple dots, and that lines up with those purple dots. Those are the same features, but the scale doesn't work. Why is that? I don't know. It's kind of mysterious, but what I've figured out is that if I take this image, which this is the 83% scale image, let's do this again. Let's get rid of that one. And I'm going to now scale it only in the vertical to 115%. Let's do my transparency trick again and line it back up, lining up with the peak. Okay, that's pretty good. Now I'm going to call this 30.9, 3 feet, 80, S83. I don't know, let's call it stretch. I'll have to work some math to figure out exactly what I've done to it. Okay, let's turn off that opacity. There we go. Now this is what we're getting. Go a little slower. And let's look at features again. Features. Okay, let's zoom in a bit. Boom, boom, boom. Okay, here's the peak. That lines up. Let's get the Humpty Hump right there. It's pretty good. What's our next feature? The shelf. Let's go over to the shelf. Shelf right there. Not bad. Okay. What else we have over here? This edge here. And put it there. It's a little off, but much better than what we had before. So I think that we're definitely looking at the same island here, from slightly different positions. The question really is there a curve? I mean, that's really what we're looking for. Now that I've got apples to apples, let's take a look. Let's answer the question. Zoom out again. Here's the image. Here's the image lined up. They're lined up. So what do? We'll say, okay, where's the horizon on these things? Let's put the horizon in blue. I'll put it green. Put green horizon for this one. Okay. Green horizon right there. It goes to there. Yeah, okay. So that's the whole bottom of the island you can see in that image. So in this image, the horizon landed in a different place. So let's make this one light blue. Cyan. Okay, right there to right there. There we are. Okay. So what does that mean? What's it mean? What does this mean? Looks to me like this whole zone is missing. This whole zone is missing. This much of the island is covered by water in this image. And in this image, the water is much lower. I think there's no two ways about it. There is a lot of missing island in this picture. Okay, so what is that? What about the compression statement? It was compression. Well, what we saw very clearly was that this is happening. Now, what's your explanation for that? Why does it not scale uniformly? Well, I could propose two potential explanations for this. One is that the original author of the video didn't scale his images quite right as he was processing them and putting them on YouTube. Possibly he got the aspect ratio mixed up on one of the images, and that's the effect that we're seeing right there. Possibly we're seeing refraction. It's possible that this image is being stretched because of atmospheric refraction. Atmospheric refraction is something that happens, and if you watch the videos, you can see it comes up in some of these captures pretty clearly, which is really, that's why I always recommend that you don't try to determine the curvature of the Earth by looking straight down the horizon, because you're looking along the horizon, you're bound to get all kinds of crazy refraction, and it muddies up the results to where you can't be sure what you're seeing. You find captures where you can see miles around the curve of the Earth, and it's because of refraction. And you find others where instead of seeing anything, you see a reflection of what's above it. So there you have it. There is some kind of strange, I'll call it compression in this image. So I'm going to give a point right there. Point to the flat Earth trio. There is some kind of compression going on in the image. So I also got to give a point to SciManDan. There is very clearly a big chunk of the island missing in this photo. So what do I think about this little reconstruction done by Ranty Flat Earth? Well, I think it's pretty good, really. We're comparing features. I agree, this is the same features here. These are the same features. These are the same features, all the same features that I've used. This drop off here, yes, I think that is this shoulder is this shoulder. I think they are the same thing. This one though, I don't agree with. They have marked this shelf as being here in this image. Let me take a screen capture of that one. Let's take a look. Here's what I want to show you about that is this shoulder that we agreed was the same shoulder in both images. They agreed, I agreed. This is that same shoulder. And what we see is that this image clearly shows two shelves. There's a shelf here, there's a shelf here, and this image only really shows the one shelf. So which of these two shelves is it? I think we have to conclude that this is the shelf, the one that's above the line, above that shoulder is that one. And that the next shelf down below is actually right there, which they have identified as the bottom of this image, but that's not going to work out because they've missed this shelf that goes there, and I think that was a mistake. So what do I think about whether the Earth is flat or the Earth is round? I think that what we can see from this image, from this experiment done by Ailsa, shows that when you go from ocean level and you go up high, 300 feet up in the air, you can see more. You can see farther. You can see lower along the island when you're up high than you can when you're down low. It's pretty clear that he's showing exactly that. That's all he's showing. He's measure the curve of the Earth. He just demonstrates that when you go higher, you can see farther. And that is completely consistent with our understanding of the round shape of the Earth. So to sum it all up, Ranty Flat Earth, you are right. There's some kind of compression in this image. And SciManDan, you are definitely right. There's a big chunk of the island missing as you get down to the waterline. And Al K, absolutely correct. You did a great job showing that when you go up higher in altitude, you can see farther. Absolutely confirmed.